I've been playing with the software on my test board, trying to see if I can get the dsPIC33C core to do what I need. Sorta have it working. At least enough I've decided I'm going to stick with these 16-bit microcontrollers for this project. But I'm quite sure I'm going to have to study up on fixed point math and the scaling of it. I've never used the DSP instructions in these processors. I think this is going to require it, and it's always good to learn something new. But I do have it functioning enough that I can test the current balance of the MOSFET power modules. This will be the first test of the two MOSFET modules working in parallel. I try to form my expectations of what I should see in the test run. I think that helps in diagnosing problems when the test deviates from what I expected. And I almost never have test runs that do exactly what I expect. For this, I'm not really expecting it to be very balanced at low current levels. At less than an amp, I expect the current balance to depend mainly on the difference in gate-to-source threshold voltage between the two power MOSFETs, and that could be quite a bit of difference. Once a couple of amps are flowing, I expect the current sense amp section to start to kick in and bring in some balance. But what level of balance should I expect? Well, the 4 resistors around the current sense op amp are 1%, and the current shunt itself is 1%. So if I was rather unlucky with part selection, current sense output could be off by 5%. One other critical part is this input resistor, so it could be off by another 1%. About 6%, maybe 7% for the entire module, worst case. Of course, there are 2 modules, and if they each went in opposite directions, that could give me close to a 15% difference in current flow. Now, I don't expect worst case, but it's good to be aware of it. But what do I expect? A 5% difference will make me very happy. 10% will be okay with the parts I'm using, but that might force me to revisit the precision of the components I'm using. Let's see what I get. I'm simply putting an amp meter on the positive input to each of the power MOSFET modules and measuring the current. So if the meters read about the same, I will be good as gold. Going to step through a range of load currents. These numbers are not really looking too good. One thing that does look pretty good is total current, unless my math is screwed up, very close to my set value. I am doing a lot of averaging on the ADC values, but the noise at the input of the ADCs is huge. 2-layer PC board, wires strung all over. Not a very good low noise layout at the moment. You can see it on the current and voltage readings. They're bouncing all over the place. But when I put a scope on it, the actual voltage is really quite flat. Okay, I'm going to stop here. There's way more difference than I want even at these currents. So here's what the data looks like. Total current on the vertical scale and % each module handled on the horizontal scale. And that's not what I was expecting. Down here in the 1 to 200 milliamp region, I was expecting the difference to be anywhere between 0 and 100%, so 23, 24, that's really fine. But up here in the 2 to 4 amp region, I'm at like 13 to 14% difference, really looking at worst case part selection range. Worst case values and the fact that from very low current up, is a gradual narrowing of the difference, makes me think I have something wrong. So going to have to take some measurements and see. Since I'm not going to need to run a lot of power through these modules to check this out, I'm going to mount the MOSFETs on some small heat sinks. Make it easy to check the voltages and see what I have. My first check is going to be the gate voltage with the load set to off. It's the minimum voltage the gate will see, and it needs to be kept under 1.5 volts. Only a 1 millivolt difference. I think that means my input resistors and op amps feeding the gate are well under 1% in difference. Okay, going to take a few readings with a bit of current flowing. First, the gate voltage with about 2 amps total. 2 to 3 millivolt difference is all. The voltage at the output of the current sense amp ideally should be around 30 millivolts. I'm reading 114. And I'm getting about a 350 millivolt drop across R10. Let's take a look at the schematic. So I'm dropping about 350 millivolts across this 150 ohm resistor. Not a lot of current, but apparently it's not able to pull it down to where it needs to be. I'm going to pull up the data sheet. Okay, I should have paid a lot more attention to this part of the data. Assuming a couple of milliamps would be fine. Not a good assumption. Certainly not good when the output is so close to one of the rails. With a 2K ohm load, 80 millivolts typical, half a volt worst case. Well, with the values I chose, this amp is looking at like a 1.7K ohm load, so it falls right in the typical range. Well, that's probably the bulk of my problem. While this op amp would do fine putting out 2 to 3 milliamps, when getting close to the rails, things do change. My gate voltage is well below 1.5 volts at off, so since I'm going to be changing these resistor values, I think I will up the gain just a tiny bit on this amp, and get the load resistance on the current sense amp up over 20K. Changing SMD resistors is just so much easier now that I have the hot air station. Just no problem at all. Going to rerun the same test with the new parts and see if I've made any headway. Now here's the data after replacing the 1.5K ohm resistor with a 20K and the 150 ohm resistor with a 1.69K. This is what I was expecting. Got a little curve in the data here. The numbers above 1 amp really look good. If it stays that good at higher current levels, that will work just fine. The one thing I'm a bit surprised at, the low current numbers are quite a bit better as well. Surprised, but not unhappy. I think I'm going to get away with no negative voltage rail for the MOSFET modules. Very pleased with that. I'm going to start seeing what parts I need for the control section. See if the parts are even available right now. I know the last couple of switching regulators I've looked for have been out of stock. But I'm one step closer to the finish line. Thank you for watching.